All right, this is the 5-1 and 5-2 review. All right, the first topic here, the first question is asking about finding all the real nth roots. So what are the nth roots of the following? So we're looking for the second root of 196. So what that means is we're looking for some number, let's say x, squared is going to equal 196. What number to the second power is going to give us 196? Well, we can either use our calculator or we can use our table. So here's 196. So the root of 196 there, the second root of 196 is going to be 14. Okay, it could also be negative 14 because negative 14 squared is also going to give us 196. So 14 squared, 14 squared equals 196. Okay, but negative 14 squared. Negative times negative is positive. So we get positive 196. So it's 14 and negative 14. Okay, 216, the third root of 216. So we're looking for some number to the third power. We can use our calculator or we can use our chart. So something to the third power, that's 216, that's going to be 6. So 6 to the third power equals 216. Okay, negative 6 to the third power, though, is going to give us negative 216. So this one doesn't work. We want positive 216. So our only solution is going to be 6, right? So when n is even, 2, 4, 6, or 8, you're going to end up with plus or minus because when you multiply a negative twice together, or 4 negatives, or 6 negatives, or 8 negatives, you're going to end up with a positive answer. Whereas if you only have 3 negatives or 5 negatives, you're going to end up with a negative, right? A negative times a negative times a negative is a negative, right? So anytime you have an odd number of negative numbers multiplied together, you're going to get a negative answer. So when n is even, it's plus or minus. When n is odd, it's just going to be the positive version. Or if you're finding the, what are the third root? What's the third root of negative 216? Your answer would be negative 6, right? But the third root of positive 216 is positive 6. All right, 625. Right here, fourth root, 625, looks like it's 5. And again, since it's even, it's going to be plus or minus 5. So 5 and negative 5. Because again, negative 5 to the fourth is positive 625. Negative times negative is positive, times a negative is a negative, times another negative gives you positive. Okay, 243. That looks like it's going to be 3, right? Fifth root of 243 is 3. And since n is 5, that's odd. It's just going to be positive 3. All right, so that's the first question. You're just finding the roots, and you can just use the table for that. Clear. Okay, the next one, in words, what does each of the following fractional exponents mean? Then evaluate. Okay, so let's first write this as a radical. So if I convert this to radical form, this is going to be the fourth root of 16 to the third. Okay, so then we're going to write that in words. It's the fourth root. The fourth root. It's really the fourth principal root, but that's okay. Fourth root of 16 to the third power. Okay, that's what this means. This is the fourth root of 16 to the third power. If we evaluate it, I can change 16 into 2 to the fourth. Okay, which gives me the fourth root of 2 to the 12th. 4 times 3 is 12. 4 goes into 12 3 times, so this becomes 2 to the third, which is 8. Okay, the other way to do this is we could have done 16 to the third, so we're looking at fourth root. 16 to the third, we can use our calculator. 16 to the third, and we get 4,096. 4096. Okay, and then we can do the fourth root of 4096, and we can get 8 equals. So either way you want to do it, you want to use your calculator, you want to change 16 into 2 to the fourth. Either way, we're going to end up with a final answer of 8. So that means the fourth root of 16 to the third power is equal to, or equivalent to, 8. Okay, the next one. This is going to mean the third root of 9 to the fourth power. Right, and if we evaluate it, this is going to be the third root of 9 to the fourth. Okay, I can change 9 into 3 squared. That's not a perfect cube though. But that's okay. 3 squared to the fourth, which is going to give us 3 to the eighth, right? Which we can split up into 3 to the sixth. Cubed root of 3 to the sixth times 3 squared, which will give us 3 squared and then cubed root of 3, which is going to be 9 cubed root of 3. Okay, if we want to use the calculator, we can put in 9 to the fourth. $6,000. So cubed root of 6,561. Okay, that's not a perfect cube, so you're going to have to find a perfect cube that goes into that. Given that this is 9, I don't think that's on our list. This one might be too big. No, it is. 729. I'm betting it's 729 here. So let's look. Calculator. Let's do 6,561 divided by 729. It's gonna be 9. Yep, perfect. So I would split this into 729 times 9. The third root of 729 is 9, and I'm left with 9 on the inside. Oh, sorry, this is 3 squared. Yeah, okay, that makes more sense. So then 3 squared is 9. Yep, sorry, 3 squared. 3 squared is 9. All right, that's example 2. On to the third type of question here. Oh, no, this one just is rewriting radicals. So again, that's, you take the denominator. So this is the 7th root of 5 to the 4th. And this is the third root of a to the 1st. Right, but we don't need to write that 1 there. We can just write it as the third root of a. Right. So the next one down here. Okay, 5th root. So if I look at my chart, 32 is a perfect 5th, right? It's 2. The 5th root of 32 is 2. So the 5th root of negative 32 is going to be negative 2. X to the 10th is a perfect root, perfect 5th, I'm sorry. Y to the 5th, though, is not. So I need to split this up. Okay, I'm going to do negative 32, X to the 10th. Okay, I need to split up the Y. So 5 does not go into 16 evenly. So the number below 16, the first number below 16 that 5 will go into evenly is 15. So I'm going to split this up into y to the 15th times y, right? Y to the first, 15 plus 1 is 16. Okay, and then I'm going to take my perfect squares. So my perfect squares are going to be the first 3 here. Okay, and then we're just going to have a y left over. Okay, so the fifth root of negative 32 is negative 2. The fifth root of x to the 10th is x squared. The fifth root of y to the 15th is y to the 3rd. And then what we have left is the fifth root of y. So there's my answer. All right, number 4, I'm sorry, 4b. Okay, perfect cubes. So is 81 a perfect cube? If we look at our table, it is not, right? So we need to find a perfect cube that goes into 81. So what I'm going to do is I'm going to do 81 divided by 2. That's, whoops, 40.5. So if I'm looking at perfect cubes, 40.5 is not in here. Okay, but it's between 27 and 64. So I know it's not going to be larger than half of it. So I know it's not going to be larger than 40.5. So it's either going to be 27 or 8. So in my calculator, I can then do 81 divided by 27. It works because that's going to be a whole number. If it was a fraction, I'd have to try 8. But it's a whole number, so 27 times 3. So we're going to split up 81, negative 81, into negative 27 times 3. All right, x to the 4th is not a perfect cube either. So 3 does not go into 4 evenly. So I need to split this up into x to the 3rd times x. All right, and then y to the 9th is a perfect cube. 3 goes into 9 3 times. So my perfect cubes are going to be negative 27, x to the 3rd, and y to the 9th. So those are my 3 perfect cubes. And then what I'm going to have left is going to be 3x. So cubed root of negative 27 is going to be negative 3. Cubed root of x to the 3rd is x to the 1st, just x. And the cubed root of y to the 9th is y to the 3rd. 3 goes into 3. 3 goes into 9 3 times. Okay, and then what I have left is 3 times x. That's what I have remaining, right? This is what I have left, 3 times x. And that should be our answer. All right, next one then. Moving on. Solving for x. So these ones you want to get the x or w in the case of b by itself. So what we're going to do is we're going to start by dividing each side by 2. Okay, so I'm going to divide both sides by 2. So I get x to the 3rd equals negative 27. Okay, I'm going to take the 3rd root of both sides. Cubed root of both sides. So the cubed root of x to the 3rd is x. And then the cubed root of negative 27 is negative 3. Okay, over here, I'm going to divide both sides by 5. So this is going to give me, let's see, 1024. You can use your calculator if you want, but 5 goes into 5,000 1,000 times, and then 5 goes into 120 24 times. Okay, and this time I'm going to take the 5th root of both sides, because the 5th root of w to the 5th is w, and then the 5th root of 1024, if I look at my chart, is going to be 4. And there's my solution. Okay. If either of these were even, so remember if you had x squared, or you have x to the 4th, or x to the 6th, then your answer is going to be plus or minus. But if it's odd, you're just going to have that one solution, one root. All right, so that's it, I think, for 5.1. Now on to 5.2. The first one is use properties of exponents. So over here, we're multiplying, so we need to add our exponents. So we have 1/2 plus 4/5. We need to get a common denominator, so that's going to be 10. So that's going to be 5/10 plus 8/10. And that's going to give me x to the 13/10. Right, and again, you can just use your calculator if you need to add fractions. If you're struggling that much with it, we can just use our calculator to add those together. Over here, I have 4/1. So between 1 and 3, my common denominator is going to be 3. So 12/3 plus 2/3 should give me 14/3. Okay, and again, if you can't do that, you can just take 4 and then add 2/3 to it in your calculator. Okay. Right, so if I wanted to do that, 4 plus 2/3 gives me 14/3. Or if you were doing the first one, you could have done control divide, 5/10, or 1/2 even. Control divide. What was it? 1/2 plus control divide, 4/5. 13/10. Okay. All right, the last one here then. X's, so I can subtract because I'm dividing here on my x's. So I'm going to do x to the 4th minus 1/3 times y to the 2/3, right? And then this is all to the 1/3. So I'm combining these two together by subtracting the 1/3 from the 4. Okay, so that's going to be the common denominator is 3. So again, that's going to be 12/3 minus 1/3 times y to the 2/3, all to the 1/3. So that's going to give me x to the 11/3, y to the 2/3. Okay, and then it's all to the 1/3. So I need to multiply both these by 1/3. So that's going to give me x to the 11/9 times y to the 2/9. Okay, and again, if you need to multiply, you can multiply those in your calculator. But we're just multiplying 11/3 by 1/3. And then 2/3 by 1/3. Okay, rewrite in exponential form. So this is the base here, the radicand is 4. And then our index becomes the denominator and the power becomes the exponent. So this is going to be to the 6/5. Okay, and then over here, really, there's a 2 here. Right, so this is going to be a to the 3/2. Okay, that one's pretty simple. We're just changing it from radical form to exponential form. Okay, square root of a to the 3rd, 5th root of 4 to the 6th. All right, add subtract is the next section here. So what we want to do is reduce before we can add or subtract them. And remember, to add and subtract, you have to have the same root or the same radical sign, and you have to have the same number under the radical as well. So the first one, I have square root of 27. So I need to find a perfect square that goes into 27. So again, the process I can follow using my calculator is 27 divided by 2, which is 13.5. And then if I look at my chart, 13.5 is right here between 9 and 16. So it's not going to be bigger than 13.5. So it's either going to be 9 or 4. So when I pick my calculator up and I do 27 divided by 9, that's a whole number, that's 3. So it's going to be 9 times 3. So I'm going to split this up into 5 square root of 9 times 3. Okay, I got to split up my 48. That's also a square root. So if I, again, follow my process, I'm going to go to my calculator. I'm going to do 48 divided by 2. It's going to be 24. So if I look at my chart, 24 is right here. So it's either going to be 16, 9, or 4. So I'm going to start with 16. I'm going to do 48 divided by 16. And that gives me a whole number, which is 3. So it's going to be 16 times 3. Minus cubed root of 24. So again, 24 divided by 2 is 12. This time we're looking at the perfect cube list. So 24 is right here. So the only one below 24 is going to be 8. So let me check and see if 24 divided by 8, it gives me a whole number. So I'm going to split it up into 8 times 3. So 8 times 3. Okay, the square root of 9 is 3. So I'm going to do times 3. And then what's left inside is the 3. Plus 2 times the square root of 16 is 4. And then what's left inside is going to be the 3. Minus the cubed root of 8 is 2. And what's left inside is the cubed root of 3. So I'm going to have, let's see here, 15 square root of 3 plus 8 square root of 3 minus 2 cubed root of 3. Okay, so I can combine these two together because they're both square root of 3s. So that's going to become 23 square root of 3. But I cannot combine it with this one because this one's not a square root, it's a cubed root. So it's going to stay minus 2 cubed root of 3. And that's my final simplified answer. All right, next one, we're going to do the same thing. So we got to split up this 162. It's not a perfect cube, so I'm going to go to my calculator. I'm going to do 162 divided by 2. Okay, 81. So I know it's not going to be, if I go to my cubed root list, 81 would be between 64 and 125. So I know it's not going to be 125 or 216, right? Those are too big. So it's going to be less than half of it. So it's going to be less than 81. So 64, 27, or 8. So I'm going to try 64 first. Okay, 162 divided by 64. Doesn't work. It's a fraction. 162 divided by 27 is 6. That's a whole number, so that one works. So I'm going to split it up into 27 times 6. Okay, 27 times 6 plus square root 54. Okay, 54 divided by 2 is 27. Okay, I'm going to go to my squared perfect squares chart. 27 is right here, so it's less. So 25, 16, 9, and 4. So 54 divided by 25 is not going to work. 54 divided by 16 is not going to work. Fraction. 54 divided by 9 works. It's a 6, so 9 times 6. Okay, and then cubed root. Again, same process. You're going to find this is going to be what's 16 times, well, I don't know, 16 is not going to work, right? Perfect cubes. So if you go to your list, 8 times 6, right? There we go. So cubed root of 27 is 3. What's left inside is going to be the cubed root of 6, right? This is a perfect cube. Cubed root of, or square root of 9 is 3. What's left inside is square root of 6. Minus cubed root of 8 is 2. What's left inside is cubed root of 6. Okay, I can combine the first one and the last one together. So 3 minus 2 is going to be 1. So it's cubed root of 6. And I cannot combine that with square root of 6. So there's going to be my final answer. 3 cubed root of 6 minus 2 cubed root of 6 is just 1 cubed root of 6, right? But we don't need the 1. And then I have plus 3 square root of 6. All right, last section is the multiplication, the binomial multiplication. So we're going to do first, outer, inner, last, right? FOIL. So I have to do 4 square root of x times 8 square root of x. When I multiply, remember, I multiply what's on the outside, and then I multiply what's on the inside. So for the first two, when I multiply, 4 times 8 is going to be 32. Square root of x, square root of x. So x times x is going to be x squared. Okay. Outer. Multiply what's on the outside. 4 times 6 is 24. Square root x, there's no squared here, so it's just going to stay x. Inner, outside, 3 times 8 is 24. 3 times square, there's no square root here, so all I have is square root of x. Okay, and then last, 3 times 6 is going to give me 18. All right, combine or simplify still. So right here, square root of x squared is x, so this is going to be 32x. Plus, you can combine these, 24 square root of x plus 24 square root of x is 48 square root of x. And then I have at the end plus 18. Okay. Next one, fourth root. 4x squared. So outside is just 1 times 1 is 1. Inside 4x squared times 4x squared is 16x to the 4th. Okay. Outer is 3 4th root x squared. Inner is minus 4th root 4x squared. And then minus 3. Okay, the 4th root of 16x to the 4th is going to be 2x, right? 4th root of 16 is 2. 4th root of x to the 4th is x. Minus, I can combine these. Minus 3 minus 1 is going to be minus 4. 4th root. Oh, I'm sorry, this should have been plus 3, right? Let's go back. Yeah, this should be plus 3. And then minus, right? So that's going to give us plus 2, 4th root x squared, and then minus 3. Okay, and that's the 5152 review.